Welcome to this class. At first, I want to congratulate the students who are studying in class 10. They are promoted from class 9 and entered into class 10, and they are now in the preparation of SEE examination also. I want to congratulate them. This is the first class of the subject Science and Technology, and this is of Unit 1, and the name of the chapter is Scientific Study. Today we are going to focus on variable, different types of variable, and the relation between the variable, and this is first part of scientific study. Okay, but do you know that variable is related to physical quantity? First, I want to recall the physical quantity. Physical quantity was taught in class 8 also. It was nicely taught in class 9 also. Now, I want to recall the physical quantity which is very related to variables. That's why let's recall the physical quantity. What is it? Quantities which can be measured directly or indirectly are called physical quantities. What is the meaning of this saying? Directly and indirectly. Just for example, if you want to measure the length of the room, then you can measure the length of the room directly with the help of an inch tape or meter stick. This is direct measurement. This is one of the physical quantity. Length is physical quantity and can be measured directly with the help of meter stick or inch tape. In the same way, you can measure breadth also. Breadth is also a physical quantity and can be measured directly. But if you have to find the area of the same room, I mean to say the area of the floor of the room, then first you have to measure length, and then you have to measure breadth, and then using a formula area equal to length into breadth, you will be able to find the area of the floor of the room. This way, area cannot be measured directly. It depends upon length or breadth. Length and breadth in case of this floor. In the same way, let's take another example. In the game of 100-meter race, if an athlete is taking part in the 100-meter race, then 100 meter is the distance that can be measured directly. But how long he takes to cover that distance, that can also be measured directly by using the stopwatch. Length can be measured directly, which is a physical quantity, and time can be measured directly using this stopwatch. But his velocity cannot be measured directly. In this case, we have to divide length by time. Then we will be able to get this velocity. So, some of the physical quantity cannot be measured directly, some physical quantity can be measured directly. All the quantities which can be measured directly or indirectly are called physical quantity. But there are many other quantities which cannot be measured directly or indirectly. Just for example, if a man is angry with some another man, then his anger cannot be measured. If a man loves another person, then love cannot be measured. Anger cannot be measured, love cannot be measured, sorrow cannot be measured. These are the quantities which cannot be measured. That's why they are not physical quantity. This way, we have to understand the physical quantity. All the measurable quantities are physical quantities, directly or indirectly. Let's take example. Distance, velocity, force, solubility, reactivity, work, power, acceleration, etc. All these are physical quantity which we use in the study of science. After all this, now I want to enter into variable. Now, what is variable? Now I want to enter into it. Actually, all the physical quantity which are used in the study of science, they are variable. That's why we were talking a lot about the physical quantity. Okay, what is variable then? We can define variable this way. In science, I'm talking about science only. There are different sectors, but we are talking about the science. In science, a variable is any factor, or it may be a trait, or it may be the condition. In science, a variable is any factor trait or condition that can exist in differing amounts or types. Looking at the definition, it seems to be a little difficult to understand. I'll make it easy for you. Look at this word, factor. Factor means all the physical quantities are factor, whether it is solubility or it is velocity or it is length or temperature, whatever it is. All the physical quantities are actually factors. Beside this, the trait is synonym, we can say property, characteristic. The characteristic or property is called trait that can also be told as variable. Just for example, salt dissolves in water. Sugar also dissolves in water. But if temperature of water is changed, then the property of water to dissolve salt or sugar also changes. Then that's why we can say that solubility, which is the property of water, can also be taken as variable. The solubility is variable, but this is a trait, or this is the property of the liquid. That liquid is water. And other liquid can also be taken. In the same way, sweetness, sour, and the other matters, just combustible or non-combustible, or substance may be combustible, another may be less combustible, another may be highly combustible. That can also be taken as variable. Variable can be any trait also. Now let's talk about the condition also. What it means exactly? Condition may be variable. If we want to find the relation between the growth of plant and availability of water, then what happens? We can take different plant in our field, and one of them will be supplied with less amount of water. In another case, we can supply more water. In another case, we can supply excessive water, and we can see its effect on the growth. This way, the availability of water, this is a condition for the growth. Availability of water is a condition that can be taken as variable. There are other also, there are many things, but these examples are enough, I think. Any factor, any trait, or any condition can be taken as variable, and they exist in differing amount. What it means? They exist in differing amount. Just for example, different pieces of stone have different mass. Mass exists in different amount, and it exists in different type also. The shape and size of the taken mass, solid mass is different, liquid mass is different. That's why the variable, we have to remember, any factor, any trait or conditions that can exist in different amounts and different type can be considered as variable. The major point you have to remember that all the physical quantities which are used in the study of science, they are variable. Okay, after this, let's talk about the relation between the variables. In the study of science, sometimes we have to study the relation between two different physical quantities or two different variables. If one of the quantity increases, another may increase or may decrease. What type of relation exists between them can be studied in experiment, in the research. And in this case, we have to understand that which variable we are going to manipulate, and effect of that variable we are going to see on another variable. That's why I want to give example. You have done this. Relation between acceleration and force was established in class 9. Look at this relation between what? Acceleration and force. Both of them are variable. We are going to compare, we are going to establish the relation between acceleration and force with this experiment. Okay, now I want to tell you a little detail about this. We did this in class 9. We are going to establish the relation between the acceleration and force when 1 Newton force is applied on a mass of 1 kilogram, then what happens? It moves and it produces an acceleration of 1 meter per second square. If you remember, this is the definition of 1 Newton force also. 1 Newton is the force which is required to produce an acceleration of 1 meter square on a mass of 1 kilogram. This is the definition of 1 Newton force also. But at this time, we are not talking about the definition of force, 1 Newton force. We are talking about the experiment. When 1 Newton force is applied on this 1 kilogram mass, it moves and produces an acceleration of 1 meter per second square. But instead of 1 Newton, when 2 Newton force is applied on the same mass, then what is seen? The motion is faster than the previous. Now acceleration is more than the previous. It is 2 meter per second square. When 1 Newton force was applied, acceleration was 1 meter per second square. When 2 Newton force is applied, acceleration increased to 2 meter per second square. Now let's increase again the value of force. If we apply 3 Newton force, then look at this, the body is moving faster than the previous. At this time, acceleration is greater than previous, it is 3 meter per second square. What is seen in this experiment, when we increase the force, then acceleration produced on the body will also increase. This is the directly proportional. We can conclude that acceleration is directly proportional to the force. When two quantities are related in such a way that one of them when increased, another also increases, or one of them is when decreased, another also decreases, this type of relation is called directly proportional. What is found here? Force and acceleration, they are directly proportional to each other. And that can be represented symbolically like this. Acceleration is directly proportional to force. This sign represents directly proportional. Okay, now why I am talking about the class 9 a little detail? The reason is very simple. All these were done in class 9, but we had no idea about the variable at that time because variable is taken in class 10. Now I want to tell you that we are manipulating the value of force. Since the value of force is manipulated and we have control over it, we are changing the value of force, so it is independent variable. And its effect is seen on the acceleration. Acceleration depends on force. That's why acceleration is dependent variable. But throughout the experiment, the mass of the body is same. 1 kilogram mass is taken. It means the mass in this experiment, mass is controlled variable. So I want to conclude in terms of different types of variable. There are basically 3 types of variable. One is independent variable, another is dependent variable, and third is controlled variable. In the previous experiment, what was independent variable? Force. Why? Because we have control over it. We are changing the value of force and we want to see its effect on acceleration. The variable which can be changed, manipulated, is independent. That's why force is independent variable. But here acceleration is dependent variable because it depends on force. More the force, more the acceleration. In the same way, what is control variable? Throughout the process, the mass of the body was taken constant, 1 kilogram was taken. That's why the mass is controlled variable. This way, this independent variable, dependent variable and controlled variable, types of variable can be understood clearly. Okay, now let's go through another example also. This relation also established, this relation was established in class 9. I am going to take example from class 9 because you will be comfortable in this class 10 if the certain example comes from class 9 previously studied. Relation between mass and acceleration. Look at this, 1 kilogram mass is taken. If 1 Newton force is applied, then it moves and acceleration, 1 meter per second square acceleration is produced. Yes, but At this time, I am not increasing the value of force, I am increasing the mass. If instead of taking 1 kilogram mass, if 2 kilogram mass is taken and same 1 Newton force is applied, what is seen? Now it's being slower than the previous. Now acceleration is less than the previous. It is only 0.5 meter per second square. Now instead of 2 kilogram, if we take 4 kilogram, then what happens? Now acceleration is very less, just 0.25 meter per second square. Now what is the conclusion of this experiment? We are comparing different variables with each other and we are deciding which one is independent, which one is dependent and which one is controlled variable. In this experiment, mass of the body is manipulated, changed. We are increasing the mass or we can decrease also. Mass is changed and its effect is seen in acceleration. That's why mass is independent, but acceleration is dependent variable. Acceleration is the product of mass. And in this experiment, what is not changed? Force. The same amount of force is applied in first, second, third, all the cases. That's why we can say that this force is what? Force is controlled variable. So, I want to conclude this. The experiment says that acceleration is inversely proportional to mass and symbiotically we can say that A is inversely proportional to m. Here the same symbol we have to read as inversely proportional because the quantity in right hand side is taken in denominator. If the same mass is taken in numerator, then we can read this symbol as directly proportional, but if it is taken in denominator, then we have to read it as inversely proportional. Here, acceleration is inversely proportional to mass. When mass increases, acceleration decreases. Now, let's conclude this. In previous experiment, force was independent variable, acceleration dependent, and mass was controlled variable. In this experiment, we are manipulating the value of mass. That's why mass is independent variable, acceleration is dependent variable, and force, which is controlled, it is controlled variable. Let's take other example also. Now look at this is a cell. If this cell is connected to a resistor, then certainly current flows from positive terminal to negative terminal. You know about this. It was told in previous classes, lower classes also. Current flows from positive terminal to negative terminal through this resistor. Now, we can measure current in the resistor by using ammeter, which must be connected in series. We can measure potential difference across the resistor also using a voltmeter in parallel connection. This way, we can measure current and potential difference using one cell. But the same can be measured by using two cells also. Using two cells, we are measuring current and potential difference. And using three cells also, we can measure current flowing through this resistor and potential difference across this resistor. This experiment was done first by George Simon Ohm, and he concluded something which is called Ohm's law. Now, I want to talk about Ohm's law and I will come back to the same experiment again. What Ohm told at that time, potential difference is directly proportional to the current. What is the meaning? If potential difference increases, current also increases. This was the conclusion of Ohm. Now, let's take the same diagram. Now, it can be represented symbiotically like this. V is directly proportional to I. V is potential difference, I is what? Current, and this sign is called directly proportional. V is directly proportional to I. Now I want to go back to the same diagram. When one cell was taken and current was measured and potential difference was measured, and then again two cells were used and three cells were used. What is the difference between these three? We are increasing the number of cells, isn't it? Increase in number of cell increases the potential difference in the circuit. We are increasing potential difference in the circuit because we are increasing the number of cells. If number of cells are increased, then potential difference in the circuit increases. We are increasing the potential difference. It means potential difference is independent variable. Its value can be increased or decreased. If we decrease the number of cells, then the potential difference will be less. If we increase the number of cells, then potential difference will increase. Now we want to see the effect of potential difference on current. In first case, the current is found less. In second case, current is found more than the previous. In third case, more than the first and second. Okay, what we did here, increasing the number of cells, we increased the potential difference. The increase of potential difference increases the current, which can be seen in this meter. When one cell is used, current is less, potential difference is also less because only one cell is used. When two cells are used, potential difference certainly increases and current is also found to be increased. When three cells are used, then potential difference again increases and current is found to be increased than the previous. This way, we are going to find the relation between what? Potential difference and current. And what is our conclusion? Potential difference is directly proportional to current. And in the sense of independent, dependent and controlled variable, now what is the conclusion? In the sense of independent, dependent and controlled variable, potential difference is independent variable because we are manipulating the value of potential difference by the increase or decrease of number of cells. And what is dependent variable? The effect of this increase and decrease of potential difference increases or decreases the current. That's why current is dependent variable. And there is another matter also, resistance. What is it? The resistance of resistor, which depends upon length of the resistor, which depends upon thickness of the resistor. This resistance depends upon length, it depends upon thickness, it depends upon temperature, it depends upon different type of material. But we are using the same. Length is not increased, thickness is not increased or decreased, and temperature is not increased or decreased, and we are not changing another resistor. That's why resistance of the resistor is same. So resistance is controlled variable throughout the experiment. Is this clear? Now I think you are clear about this. We have taken the variables related to electricity also. We have taken variables related to force and motion also. I think now you are clear, and at this stage you can define independent, dependent and controlled variable very nicely. I want to define here, and then you will be able to understand more clearly. Independent variable, the variable which is manipulated to find its effect on the another variable in a research or in an experiment, is called independent variable. In different research or in different experiment, we increase the value of one of the variable and we want to see its effect on another variable. And the variable which can be manipulated is what? Independent variable. Just for example, there are different masses of different stone, piece of stone, or we can say the pieces of iron. Small piece of iron has less mass, a little more big piece of iron has more mass, another bigger one has more than the previous mass. The mass when increases, then weight of that piece of iron will also increase. If we take their weight, then it can be declared very easily that whenever mass increases, the weight of the iron piece also increases. It means mass of the body is what? Independent variable. It is available in different amounts and it can be manipulated and its effect on the weight can be measured. This mass is independent variable. Now let's talk about the dependent variable also. The variable which depends on another variable in a research or in an experiment is called dependent variable. Just for example, if we have a solution of salt in water and we are dissolving salt in water, and a condition comes when no more salt can be dissolved in the same water. But if we heat it, then more amount of salt can be dissolved in it. What it mean? It means the increase of temperature, we are increasing temperature, it is dependent variable, but the solubility which increases with the increase of temperature is dependent variable. Solubility is dependent variable. There are many examples. We have taken other example in previous experiment also. Now what about controlled variable? Look at this controlled variable. The variable which remains constant throughout an experiment or scientific research is called controlled variable. In previous example, I told you about the growth of the plant. Growth of the plant depends on availability of water also. And if we want to prove it or we want to find with experiment, then we can take different plant and we can use amount of water differently. In one of the plant only once in a day, in another plant twice a day, in another plant more amount of water, in another plant excessive amount of water, and we can see its effect on the growth. Actually our target is to find the rate of growth, how it is related to the amount of water. The water at this time, amount of water is what? Independent variable, we can manipulate it, and growth is dependent variable. But throughout the experiment, we have to take care about the sunlight also. If one of the plant is taken in bright sunlight throughout the day, another is taken in less sunlight, availability of sunlight is less because of it is in certain place where sunlight is not proper, I mean to say maybe in shade. In this way this variable, availability of sunlight, should be controlled. Otherwise the growth of plant, how it depends on water cannot be declared. Availability of sunlight is controlled variable. In the same way, if in one case we are using fertilizer, in another case we are not using fertilizer, then this cannot give us correct result. So if we are using fertilizer, we have to use fertilizer to all the plant. If we are not using fertilizer, then we don't have to use this to any plant. This availability of fertilizer, availability of sunlight should be controlled. These are controlled variable. Yes, this way we can understand about the dependent, independent and controlled variable. Now after all this, I want to tell you about the position of variable in the equation, and the variable, how do we represent the relationship between the variable graphically. Now we are going to talk about what? Equation. In the equation, how do we represent variable? Look at the board. We know that displacement is equal to velocity into time. We know this. It was taught in class 7 also, 8 also, 9 also, but at this time we are talking about the variable. In the context of variable, I want to tell you these three. This velocity of a body is, if just 5 meters per second, after 2 seconds, what happens? It will cover the distance. After 2 seconds, it will cover the distance 10 meters. But if velocity is increased, if velocity is made 10 meters per second increased, we are manipulating the value of velocity. That's why this is independent variable. If its value is increased to 10 meters per second, then within the same time period, 2 seconds, it will cover 20 meter distance. If the value is again increased 15 meters per second, then within same time period 2 seconds, it will cover more distance. What it means? Here V is independent variable, I am writing shortly, and S, displacement, is dependent variable, I am writing here shortly, and we have taken the same time, this is controlled variable, isn't it? Now looking at this equation, you can understand very clearly that dependent variable is usually taken in left hand side of the equation. S is taken in left hand side. This displacement is taken in left hand side. Dependent variable is taken usually in left hand side, and independent variable, we have to take independent variable in right hand side. In the same way, we can take other example also. Just for example, another example, E equal to mc square. This is very famous equation. Yes, if the mass, destroyed mass is more, if we destroy more mass, then the amount of energy produced by the destruction of mass, amount of energy produced by the destruction of mass will be more. This is independent variable, this is dependent variable, and the velocity of light, which is denoted by c, is a constant. Normally, dependent variable is taken in left hand side and independent in right hand side. I want to take another example also. Do you remember this pressure is equal to force by area? It was taught in different classes, different lower classes also. We know that pressure equal to force by area. Now, if we increase the force, then certainly pressure will be more. If we decrease the force, pressure will be less. It means pressure is dependent variable and force is independent variable, and dependent variable is usually taken in left hand side and independent in right hand side. This way, graphical representation of this variable will be like this. Dependent variable is in left hand side, independent the variable in right hand side. Okay. Now what about the graph? Dependent and independent variable in graph. Look at this graphical representation of variable. This is a vertical line, y-axis. This is horizontal line, x-axis. And independent variable is always taken in x-axis, and its effect is seen in dependent variable, which is always taken in y-axis. Now, independent variable in x-axis, dependent variable in y-axis, and this is the graphical representation. If they are directly proportional, then graph will be like this, and if they are inversely proportional, graph will be like this. This graphical representation of Ohm's law, let's take example of this. This y-axis, x-axis, we take potential difference in x-axis. Why? Because this is independent variable. We are manipulating the value of potential difference, and its effect on current is measured. And what is found? This is the graphical representation of what? Ohm's law. Okay, after all this, now it's time for question. I think you understood all this independent, dependent variable. Whether your understanding is good or not, I want to verify with this question. Which of the following represents the independent, dependent and controlled variable respectively? Just look at this, independent, dependent and controlled variable respectively in the study of pressure exerted by a cuboid on a surface. Now options are given here. Yeah. Now it can be understood very clearly with the help of a block. I want to show the cuboid. Look at this. Look at this is a cuboid. This is the length, and this is breadth, and this is height. Length, breadth and height. And if it is placed this way, what, length and breadth wise, then it exerts pressure on this surface, isn't it? And the surface area through which it exerts pressure is this, length into breadth, isn't it? And if the same is taken this way, now look at this, now it exerts pressure and length and height wise, isn't it? Length and height wise. Now if it is taken this way, then it exerts pressure from this surface area, which is its breadth and height, breadth into height. Now when it is taken this way, then pressure becomes less. When the same is taken in this way, pressure will be high. But in this case, pressure is in between those two previous conditions. What it mean? What I mean to say, we are manipulating what? We are changing what? Surface area. This surface area now exerts pressure. but another time we are changing the surface area now less than previous. Now another time we are changing surface area this one only. In this way surface area, we are changing surface area, it means area is independent variable, and effect of this change of area is seen in what? Pressure. That's why pressure is dependent variable. But weight, throughout this experiment, weight of this body remains same. Weight is controlled variable. That's why remember this, area, pressure and weight, they are independent, dependent and controlled variable respectively. We have to search it in the given option. Look at the option. Here in the option we have to see what? First area. First case no area, this here area. After area we have to see what? Pressure. Pressure is dependent, here it is weight. No, this is not correct. Area, pressure and weight is given in fourth option, then that's why fourth option is correct. Area is independent variable and the pressure is dependent and control variable is weight. Weight is taken constant. Okay, now let's go through another question also. This is a little different than other question. A statement is given, look at the statement. The number of dependent, independent and controlled variable in an experiment is always one each. What is the meaning? Dependent, there is one dependent variable, one independent variable and one controlled variable in any experiment. This statement says so. Now there is argument 1. In the experiment and in research, the effect on the dependent variable is studied. Is this correct? And argument 2, another matter is told, dependent variable is a cause and independent variable is its effect. Looking at all these, you have to select one of the option. 1, 2, 3, 4. Now let's verify with the answer with the options. Statement and argument 1 are correct. Is it? Look at this. The number of dependent, independent and controlled variable in an experiment is always one each. Is this correct? No. There is always one dependent in an experiment, one independent variable in the experiment, but controlled variable may be 1 or 2 or more than that also. I told you about the growth of the plant and its relation with availability of water. At that time, the condition of this sunlight and the condition of the fertilizer should be controlled. I told you about this also in previous example. Here we have 2 other variable also which are controlled variable. That's why this statement is not correct, because control variable may be 1 or more than 1, but dependent and independent variable is always one each. That's why statement and argument 1 are correct. This option is incorrect. We don't have to see this because statement is incorrect. Now let's talk about the second. Only argument 1 is correct. Okay, let's go through argument 1. In the experiment and in research, the effect on the dependent variable is studied. Is it? Yes. Effect on dependent variable is studied by manipulating independent variable. This argument is correct. But here only is told. Maybe second argument also correct. That's why this option is suspended. Yeah, may be correct, may not be correct. Now next. Statement and both the arguments are correct. No, this is wrong because previously statement is incorrect, we have decided. That's why third option is cancelled. We have only second option existing, second option. Now let's see 4. Argument 1 and 2 are correct. Look at this 2. Dependent variable is a cause and independent variable is its effect. Is it? No, this is just opposite. Actually, this dependent variable is the effect of independent variable. Independent variable is the cause which affects the what? Dependent variable. That's why this argument 2 is incorrect. So we have to come back to the second option. The second option is correct. Okay, today I told you about the variable, types of variable And in different experiment, how do we declare this is independent, this is dependent, and this is controlled variable? That also I gave you different example. I think this class will help you to understand the subject matter related to variable. We'll meet in another class. Thank you.